what should the charge carrier do? This thing is moving this way and the charge carrier has to catch up with A. To catch up with A, suppose the time required is t prime. So during that time, the charge carrier will move this distance. It would have covered, that distance is L0 by gamma plus, that thing is moving, plus it will cover a distance V times t prime, because it is moved for a time t prime. So t prime from here is L0 by gamma divided by Vs. Now I can calculate Vs prime. Today only we did that. Addition of velocities, Vs prime is equal to, Vs prime is the velocity of, in this frame, Vs is the velocity in this frame. So I know the relation between these two. I have already written that. That is, Vs prime is Vs plus beta. It is the invert transformation plus 1 plus beta. So now, all I need to is substitute all this there. I will skip the algebra and one can show that this is indeed a positive number and works out to be gamma. After this, it is just algebra. Do the algebra and it will come out. So what is the meaning of that? In the first frame, it is switched off for some time. In the second frame, it is switched off for a longer time. In fact, it looks like it is not switched off at all, but it is actually switched off for a longer time. The important point is that I cannot have signals travel faster than speed.
So
I have not.
in morning beta is equal to B upon C yesterday. B by C.
Oh, beta is just
B by C.
So much for Shastri's parameters. Now, let's come to Bell's question. Anybody would like to answer whether the spring will break or not break? Alright. Now, after some time, the rocket is having a velocity v. Right? Both the rockets. So, the length of the string is also moving with velocity v, but its length is L. Its length is L in the moving frame with velocity v. So, what will be the rest length? More or less? This is the contracted length. Because I am seeing a moving string whose length is L. So, its original length should have been gamma L. So, in the rest frame, it would have expanded. So, the string would have broken. It is in the rest frame that its length L is the same. I suggest there are many other articles in speakable and unspeakable in quantum mechanics. And Bell, of course, is one of the most original authors in many of these things, including the Bell's inequality. This is something which I suggest all of you should look at. The book, it is in it's called the Speakable and Unspeakable in Quantum Mechanics, right? It's quite a thin book. It's not a very.
Originally published in 1987.
The book.
Okay. Now second edition was published in 2004. Introduction by Alan.
Oh, I see.
Author is who, sir? Bell.
Pardon?
Author written by? Written by?
Bell. Yes. J.S. Bell, right? Answer is yes. So now let me get to the The thing is, actually, A and B are not symmetrical. Why? Because B is going up to this place in one frame, some kind of a frame. Then he is going from a frame which is moving with the velocity v in this direction and instantaneously transferring himself into another frame. So we have to understand how this transformation takes place, and that will give us the answer to what is actually happening.
Sir,
Yes.
there is question.
Yes.
A and B starting and accelerating together is not a problem because they have synchronized clocks
Okay. In which frame?
in their frame. I mean,
In movement.
at initially at rest frame they are.
Right?
Now they accelerate.
Right?
So they fire engine simultaneously because they were in the same frame.
Okay.
Okay, so I mean for them that is not a problem.
Okay.
But the string will not have that information simultaneously. Is that a
Well, it is the part of the debate is there on that. How rigid can the whole system be? In fact, this takes us to another question. What is the, there's no rigid rod. What is the maximum proper length that we can have for a rod when it is accelerating? One can discuss this. Because the front end and the back end need to be fired at the same time in one frame, but that will not look same. And there are issues associated with that. There are also nice articles associated with that. That will take me away from what I am doing now. So if you are interested, I can give you references. Okay. Now, so let us look at the equations for the twin paradox. My B is the S prime frame. This, after transformation, I will call that double prime, S double prime frame. So this is my S prime frame. That will be S double prime. So let me write some of these equations. To start with, x prime is 0, the B is at x prime equal to 0, and his clock, when he reaches the point in which he is going to turn, his t prime is equal to t. So, at x equal to 0, this is my x as seen in the frame. Let me redraw the diagram here. That equation is t minus vx by c squared equal to t divided by gamma. So, here is my expression, here is my capital T. If I draw this line, this is my line T. This is T by gamma. This is equal to T gamma. This is gamma. I should follow this line. Because that is T here, this will be gamma. So, when this simultaneous of this frame, this will be my equation T prime equal to T. That will be my simultaneous. Okay, I come up to here. When I am looking at the clock of A, I would have seen T0 by gamma is what this would have read, right? Now I have jumped my frame. did I jump the frame? I jumped the frame when my t prime was t, x prime was 0, which corresponds to the other frame. So my t, this is the time in which I have jumped. So t is gamma t prime plus v x prime by c squared, which is equal to gamma t. So according to A, I have made the jump at the time t to the frame, and what will be x? X will be v gamma t. At this time, jump to S double. So he made the jump. But equation in x double prime are essentially t double prime related to it, t double prime and x double prime are related to x with the inverse way, because my velocity v is in the opposite direction. So I can rewrite this equation as t double prime. As far as t double prime is concerned, it is t, because he has jumped at time t. As far as he is concerned, it is t. So I will write it as t prime minus t. This is my basic equation. Is gamma times t minus gamma t plus v by c squared x minus v. Gamma. So now let us look at the line for him. What is the time in which he will see for x when t prime equal to t after having jumped into this frame? For him, x will be 0. So t which he will get will be gamma t. From here, t will be gamma t plus gamma v squared by c squared, which will be, I will write it as 2 gamma t plus minus t into gamma minus gamma v squared by c squared, which is equal to 2 gamma t minus. So, the line of simultaneity for him, moment he has jumped, he actually misses out all this time. This is 2 gamma t, and to him, this is the place of simultaneity for him. This is the line for him was t prime equal to t. This was the line t prime equal to t. Now, this is the line t prime. So, let me analyze now. I am going here, B is watching the clock of A. When he is here, he sees this clock. Moment he makes a jump, he misses this time. He only sees this clock. So, all this time has elapsed, which he is unable to look at. So, the total time 2 gamma t is accounted for with T by gamma for him here. Suddenly another, notice it's again T by gamma from 2, this is again T by gamma. The rest of this is not available to him because of the sudden jump which he has jumped. So that is the real reason for him to see the way it is. So the two will disagree, and that will be the answer that you will get, because this frame is a different frame. That in principle there is an acceleration associated. That is the twin paradox. Now let me discuss a little bit how things look like. There are two things associated with this. This is a point which will clarify some of the doubts which have been coming. What we have said about length and so on is different from taking a camera picture of an object. If I take a picture of an object, then the velocity of light is involved, because the picture is taken at a particular time, and the object, if it is moving, then the object, by the time light took, the object might not be where it is now. It would have moved a little bit. So to understand this, let me take the following example. I will think of some kind of a square block here of length L square moving with a velocity v, and I am taking a picture of that very far away with a camera. And I will assume that it's so far I am getting parallel light from there, and I look at it. Notice the back end. If I see the camera, let's call this A, B, C, D. The light, if it reaches here, the light from C must have started earlier for it to reach camera at the same time as A. But if it started earlier, it would have been behind. Right? So if this distance is L, the time CTC would be earlier from TA by L by C. So I would not see it at C in my camera, I would see it at a place C prime, which will be V times L by C. So how will the picture look to me? My picture will look, C will be C prime, will be here, and A prime will be here. And of course this would have looked contracted. This would be L by gamma, and this distance to me would be V by C, sorry, V L by C. Okay? So if I think of it as a square, what I would see is one line here of length L beta, another one here L by gamma. This will be my A prime, this will be my C prime, this will be my B. Is this clear? Now let me look at it from above. That is, this way. When I am doing it from there, I can think of this thing as a rotated object. Let's call this angle alpha, and if this is my L beta, this one is my L, then this is my L. If this angle is alpha, this is L cos alpha. What is L cos alpha? It will be L, this is L, so that will be L into 1 minus beta square. to the power half. So that is nothing but L by. So what do I get? This L by gamma which I saw here, it will look like it is a rotated object. So if I have an object which is moving very far away, I will see the backside also. Why? The backside emitted light at an earlier time when it was not being blocked by the front side. So I will, if I just think of it as slightly rotated, that will answer this explicit situation. But it turns out that this is not the complete answer. The answer is very nicely given by a paper by Matthews and Lakshman. I have actually a copy of that paper, in which he has resolved several of the paradoxes associated with this. Again, that is published in Novecimento, and it's a very, very beautiful paper. Now, there is one more point which is the following. It may appear a particle can travel with a velocity faster than light. Let's see how that can happen. You are sitting here and you are receiving light signals from a particle which is moving in this direction with a velocity v. This way. Suppose this distance is x to start. At time t equal to 0, a light signal has been sent to you. It reaches you at time tr, which is x by c. T receiving is x by c. After time dt, this distance it has traveled is v dt. Okay? Next, it sends a signal after this time. So, signal which I am going to get is tr plus dtr, which is going to be firstly x by c plus dt plus, this is not x by c, it will be, how should I write this? It will be, right? dt is the time in which it was done, plus it will be x minus v dt. So dtr is equal to dt. X by c cancels. 1. Velocity as seen by here, as seen by receiving light signal, is dx by dtr, which is dx by dt times 1 minus v by c, which is v by 1 minus. So, in principle, I have a number which is I am dividing by 1 by less than 1. In principle, this can become. Incidentally, such astronomical observations were seen, and this has been explained clearly in the paper by Lakshman and Matthews. And this is the cause of it, because you are seeing a signal, and the way you will measure the distance is by increasing the solid angle of that object, which is a standard object in astrophysics. And this in the 1950s, people were surprised to see some objects moving with a speed which looked like, and the explanation came out very naturally. Okay. Now, there is also one more thing, a similar situation which can happen, in which instead of length dilation, you may have a length increase. And let me explain how that can come about. And then I'll just briefly mention express paradox. This is also a very simple situation. Think of an object of length L this is minus L by 2, 0 plus L by 2. Moving with the velocity v. This of course in the next frame. Assume that that object was lit for just some very short time in my frame T prime. Okay, the object got lit. T prime is the frame. Say T prime equal to 0 is when the object was lit for a very short time. Let's see how will it look like in, this is my T prime x prime, Tx, in my frame here. T, this is minus L by 2. And what will this be? T would be, of course, my T is gamma T prime plus V x prime by T squared, and x is gamma x prime plus. So I put this, and my T would be, what should I write? Gamma minus gamma V by C squared, and my x will be gamma minus gamma. Then let me talk about O. O is 0, 0, so this will be 0, 0. No problem. Let's go to Q. Q will be 0 L by 2, and this will be gamma V L by 2 C squared, and that will be gamma L by 2. So this will be lit, P will be lit at time minus gamma V by C squared by 2. That's the time in which this will be lit. And it will be at a position minus gamma L by 2. This will be lit at a different time, at a greater time than this. But suppose your camera is such that it cannot resolve this kind of time. Suppose your camera is such, after all when a camera has a delta T, suppose it spreads over this region. What would you see? You would see the back at minus gamma L by 2, the front at gamma L by 2, so you will say the length of that is gamma L. So, if you take a picture, then the resolution of the camera is very crucial in seeing what is happening here. Because this may occur here, this may occur, and if the resolution is poor, this can happen. And these are the kind of things which have happened, and that's how these things have been resolved. Okay. Now the last paradox I will mention is that of Ehrenfest. It is the following. I have a disk, and I have a table in which I have cut this board, and this disk is here. I mark the disk by various degrees. Say I have marked it 360, and there are 360 marks outside here. This is the Ehrenfest paradox. I hope my spelling of Ehrenfest is correct. Okay, good. So this is, I have marked it. This is also 360 degrees. When the disk is at rest, all these marks will coincide. If mark 0 coincides here, this is mark 0, that is 0, next 1, 1, and so on will coincide. Now, let me think of the disk rotating. When it is rotating, if the marks are nearby, for me, for an outsider, this, if 0 and 0 prime coincided, at that time, 1 and 1 prime cannot coincide, because this length has to be less than the other length. So, if 0 prime coincided with this, 1 prime will not coincide. It will be a little less. 2 prime will be further less. Let me go around the circle. When I come back, I will say 0 prime will not coincide with 0. Right? So I started by saying 0 prime coincided with 0, and I went around once, and I came up with the statement saying 0 prime. And this again has produced a large number of papers, and the answer to it is it's a very nice paper by Braun in American Journal of Physics, but this doesn't completely answer all the questions. This is related to some phase of which Professor Mukunda talked about. So I think you can see a variety of interesting problems in special theory of creativity. This can keep our interest alive in the subject, even now. Thanks.
So all the time when we are considering the example, previous example, all the time we were
This example you are
all the previous example excluding this.
excluding this, yes.
So in all the cases there was motion linear motion.
That's right.
This is the only example wherein you are talking about contraction. So how is the length contraction? Then how the length contraction will take?
No, length contract. If I think of it, small length, if it is rotating, this is having the radial velocity. So sorry, tangential velocity. Right? So if, as far as I am concerned, it is moving with respect to me in this direction. So there is a contraction there. There is a contraction there. If that velocity is in this direction, that small thing. So I have several such observers, and all of them